So I'm going to take this vector and I'm going to write it in its component form, which is a little bit less scary looking to me. It's like a little ordered pair form. And because all a vector is it's going to point to this point. I'm going to go negative root 3 on the x and 1 up on the y. And my vector will start at the origin and point to that point. So this is vector v. It went negative out root 3 that way and 1 up that way. So they want to know its magnitude and direction. Magnitude is a fancy word for length. And when you have it drawn, you can see that you can find the length of this just using Pythagorean theorem. You know that this squared plus that squared will equal that squared. So this length will be the square root of root 3 squared plus 1 squared. So a lot of times you'll see that formula, the square root of a squared plus b squared is the magnitude. Square root of a squared plus b squared when you have it written out in a component form ab. You'll see that formula, but you don't need to memorize that formula. So long as you can draw a little picture and you know your Pythagorean theorem, that's what it comes from. So when we simplify this, root 3 squared is 3 plus 1, so it's the square root of 4 is 2. So our magnitude is 2, so that's that length there. And then they want us to figure out the direction. And the direction is a fancy term for the angle it makes. So when we make our angle, we always start here at the positive x-axis and go counterclockwise. And so we're looking for that angle. Now fortunately, we recognize this as a 30, 60, 90 triangle. Otherwise, we'd be a little in trouble without a calculator. So, but this is a 30, 60, 90 triangle. The 30 is across from the shortest side, the 1. And so if that angle's 30, then this angle didn't quite make it all the way to 180. It fell 30 short. So its direction must be 150 degrees. That's what that angle is there. 150 plus the 30 gave me the 180. And that is all there is to that.